Hey everyone, my name is Venelin, and in this video you're going to learn how you can use AI agents with LangChain and Llama 3 in order to build an app that writes and edits tweets. We're going to start by having a look at what AI agents are, what the CrewAI library is, and how we can use all of the components in order to build a real-world application that is also editing, writing tweets, fetching data from given URLs, and doing some research for us. Let's get started. If you want to follow along, there is a complete text tutorial that is available for ML Expert Pro subscribers. It is within the bootcamp and then AI Agents in Action. Here you can find the complete text tutorial along with the source code. So if you want to follow along, you can simply get here and get all of the code that is required in order to run the project. So if you like to subscribe my work, please consider subscribing to ML Expert Pro. Thank you. You have probably already heard about AI agents and libraries that can help you build agentic applications such as LangChain, CrewAI, and AutoGen, but most of the examples that I found online are pretty simplistic, and in this tutorial we are going to have a look at much more realistic or real-world-like application that is actually useful. And I'm going to start by having a look at what agents are. We're going to have a brief look on Llama 3. Then we're going to have a look at why agent ops are important. And this means that we're going to be doing some observability and walking of the steps of the agents. And finally, I'm going to show you the actual architecture that we're going to be using, or diagram of the application that is for writing tweets. And then I'm going to go over the VS Code source code with you. So this is taken from the CrewAI library, and this essentially answers the question, what is an agent? And they say that is something, the autonomous unit that is performing some action, making decisions, and then it can communicate or be in a team with other agents. So this is really important when you try to think on a conceptual level of what agents are. But I would like to think of agents are something that you can give a task, and then the task is given to essentially an LLM. And when the LLM receives this task, it can probably try to answer it or use a function or a tool that is going to be helping him or her to complete the task. This is pretty much the way that I think about agents. And then essentially teams of agents are these communications that can go from a single agent and take the output to another agent, etc., etc. So again, we have Andrew NG that is pretty much very interested in agentic design pattern. And here he has this very long tweet, and he says that agents are essentially very useful because you can create simpler tasks for more complex tasks or break down complex tasks. And here he says that one of the important reasons of actually doing agentic applications is that they work. And what this means, he means by that, is that we have some benchmarks that show us that if we are using agentic approach to building applications, you can essentially get better results on some specific, at least, evaluations. And here you can see that raw zero-shot examples from different models such as GPT 3.5 and GPT-4 are performing much worse compared to their agentic approaches. So this is really important to take in mind. And here we're going to have a look at, again, they work. And you can essentially solve more complex problem, again, by breaking down complex problems into simpler tasks. And then you can essentially focus on different tasks. For example, you can have an agent that is, for example, a software engineer, and his job would be just to write some code. And then you might have an editor or a writer that is taking the code and writing a tutorial based on that, etc. And again, one really important part is that debugging LLMs or LLM applications is really hard. So if you split the tasks into different agents and try to debug different tasks, this would be essentially much easier compared to debugging a whole large prompt, essentially. So keep that in mind. And again, one of the more powerful things about agents is that they can use tools. Of course, you can essentially use tools or function calling with LLMs, but doing so in agentic behavior is again allowing you to split the responsibilities between different agents, and different agents can have a set of different tools. Again, this might help you solve essentially more complex tasks. And pretty much the framework that is the standard for doing agents is reasoning and acting agents. And here you can see an example. We are going to actually see this in the works of the CrewAI library. Essentially, what you have here is a thought, then an action, and then an observation based on the action. So this is essentially how all agents are going to work. You are going to give it some task, and then the agent is going to understand the task or read the task. Then it is going to assume or create or do some action, and then based on the action, he or she is going to take a response from that, and then this will be the observation of this agent. And this is essentially taken from the CrewAI library again. This is the process that the library is using. And you can see that you have agents, you have tools, you have tasks, and then you have a process. And during this process, or after the process is complete, you get some outcome of your crew or your team of agents. And we're going to have a look at what this or how this works in practice. And one important note is that you would like probably to use a local or free LLM. There are many reasons to do that. Again, one of the first one is that this is actually free to use and can be faster and cheaper. If you are using the Grok API. Currently, this API is free and it is much faster compared to GPT-4o even. And then you can essentially fine-tune your models in order to be better at the task that you're trying to do. But from what I've seen, and I've tested pretty much GPT-4o with Llama 3, currently Llama 3 is not that great with tools usage. Again, it is good, but not that great as GPT-4o. And if you are going to be using more complex workflows, you might have some problems with that. And let's say the reasoning capabilities of Llama 3, even the 70 billion parameter model, are not that good compared to GPT-4o. This is expected since this model is much lower on the leaderboards in pretty much everything. So you can expect that if you pay for GPT-4o, you're going to get much better results. But in this example, I'm going to be using just Llama 3. So you can essentially recreate what you have here for free using the Grok API. And a note on agent ops. What is really important when building such applications is to have a look at what the agents are doing behind the scenes. And for example, CrewAI is not really good at presenting all of the prompts. So what I did here is to write some callbacks that are going to help us understand a bit better what is happening behind the scenes. And if you want to debug your tool usage, for example, or your prompts, then you pretty much are going to have a much easier time using the tools that I'm going to provide with the source code of this project. And of course, there are some free and open source tools such as LangChain and LangFuse. And what we are going to build is essentially a tweet writing assistant. We're going to be giving a topic and then a URL on which a tweet must be written. Then we're going to be giving a list or a set of tweets on which their writing style is going to be analyzed. Then we are going to get a tweet that was generated by an agent. And based on the original tweet, we are going to be actually adding a critique. And this critique is going to be essentially writing 3 different versions of the original tweet. And essentially is going to save the versions into a text file. So this is the architecture or diagram that we're going to be using. We are going to get a user that is inputting a topic, URLs, and a suggestion. Then we are going to be given the first agent, which is going to be a scraper agent. He is going to take some URLs and scrape their contents from the net. Then we're going to get a list of tweets, and along with the text, we are going to be creating a research report. And this report is going to be given to a writer, which is going to be taking the report and then writing a tweet based on that. And then an editor is going to be producing 3 different versions of the original tweet along with the research report. And this is essentially the output that we're going to get. So here is an example of an input. I have a look at, for example, Andrei Karpathy has built this GPT-2 retraining experiment. And this was essentially the tweet that the project that I'm going to show you gave us as an output. GPT-2 with LMC in just training for 90 minutes for $20, and some details of the training and the experimental results. And I'm not really famous on Twitter, but when I posted this tweet, actually Andrei Karpathy liked my post. So this was really interesting. And yeah, let's have a look at the implementation. Here is the TweetCrafter project, and you can see the structure of it. You have some files right here on the top of the project. We have a data directory, notebooks directory. We have some walks, output, and then the essential parts of the project with some Py files, which we're going to take over or cover together. Essentially, this project is using Poetry. So here you can find the dependencies that we're going to be using. Those will be available, of course, within the repository of the project. So what is really important of this project is this app.py file. And in here, you can see that I'm importing a lot of the agents and tasks and models from this project. Let's have a look at the overall picture of what is happening. First, I'm starting with creating some walks directories, etc. And then I'm going to be creating the LLM that we're going to be using. Again, I have 4 different agents, and each of those agents is given a task. So I'm creating the scraper agent, researcher agents, writer agent, and editor agents, just as we saw in the diagram at the start. And then we have an individual task for each one. And here you can see that the first tasks are pretty much independent. And then the third task is giving the context of the research content. Then the editor task is going to be essentially giving the output of the writer and the output of the research report, essentially. And the crew is going to be pretty simple. We're going to be essentially enumerating all of the scrapers, all of the agents and all of the tasks in their order. And you can see that we are using a sequential process. So what this means is that once the first agent is going to be essentially done with the task, then the next agent is going to take over. And this is the process that we're going to be taking. I want maximum verbosity, so I'm going to expose to verbosity equal to 2. And then I'm going to be using the default logging to have a look at why this logging is actually not enough. And here is essentially the summary of the key new features of Phi 3. And I'm going to be passing in this link. Let me show you. So this is the URL that we're going to scrape for our project. You can see that we have a lot of technical information right here that is regarding the Phi 3 model by Microsoft. And this is the vision model with 128K tokens as a context. Next, we're going to be giving a suggestion to the essentially the crew, and I'm going to show you where all of these are going to be used. And then I'm going to kick off this and then get some usage metrics. So the next part that I'm going to show you is right within the TweetCrafter project. And here we can start with the models, which are pretty simple. And here you can see that this project at least supports 2 models, and I'm going to show you those in the config file. So first we have Llama 3, and I'm going to be using the ChatGrok API for that. You can see that I'm using the 70 billion parameter model, and I'm passing in a callback, which is a custom callback that is essentially going to be outputting the prompts for the model. And then we have GPT-4o, which is using the chat OpenAI. Here again, I'm passing in this callback. I have a very simple config file, which is essentially designing or giving us all of the outputs. For example, most of that is given to the output and then the walks. And here I'm essentially specifying the model. By default, we're going to be using Llama 3. Next, I'm going to show you some of the agents, or all of the agents actually. So let me get rid of this. We have the scraper agent, pretty simple. We have arrow, go, and backstory. You can see that the goal of this agent is going to be just to scrape some URLs. One of the important parts here is that we are using the scrape website tool, which is essentially a CrewAI tool from the CrewAI tools library. And this is essentially going to take an URL and provide this URL or get this URL data. And here I'm specifying that this is going to be using the scrape tool and extract the text. I don't want any delegation of this or this project, this agent, since we're using a sequential process. And the step callback is essentially a way for us to hook in with what the agent is doing. And here I'm using a custom callback. Then we have a technical researcher, which job again is to write a technical report based on the informations provided in the URLs. Pretty similar. Again, step callback. Then we have a writer agent. This is a senior social media writer. And the job of this one is to essentially get the research content by the researcher and use the retweets tool, which is going to be a custom tool, which we are going to define. And based on that, it needs to write essentially a tweet that is focusing in the artificial intelligence, machine learning, large language models, etc. So the final one is going to be the senior tweet editor, and its job is going to be to create 3 different versions of the original tweet, and it's going to be using the save tweet tool in order to save the original tweet and the tweets that it has created. Again, this is using a custom tool called save tweet, which I'm going to show you right now. So the tools are pretty simple. They are essentially using the tool annotation from the CrewAI tools, and I have just named them save tweet and retweets. One important note for you to keep in mind is that if you are passing in a parameter, it is a good idea to specify its type. This helps with the prompts and the inference of what the tool is. And this is essentially the markdown or the document string of this tool. And then for the read of our tweets, we are essentially again using a markdown file to read the tweets, essentially the database of tweets that we're going to emulate their writing style based on that. Finally, we have the tasks, and they are pretty simple. But here we're going to be using some of the inputs that were provided. For example, for the scrape content task, you can see that the URLs are actually provided from the Crew. Then the research content task is pretty simple. Again, we are having a look at the topic that was provided, and the task is to just write a research report. Then we are having the right tweet. We are limiting the number of characters within the prompt. And then we are saying that we want hashtags and emojis if those are relevant, of course. And then the suggestion is actually given to the editor, and its job is to, again, create the 3 different versions. So this task is covering that. And the final output or goal of this task is to save the original tweet and the 3 versions that were created. Here you can see that pretty much every function is taking context, at least these 2, since we want some context for those. And then the agents are provided as an input or a parameter to these functions. The final part is going to be the callbacks, but those are not really that important. They're just specific to what we have here. The LLM callback, which is going to be given to the essentially GPT-4o and Llama, is essentially taking this event, which is the current text from the prompts, and saving it in a walk file that is provided as a walk path in the constructor. And I'm going to show you the results of that in a bit. And then the step callback is essentially specific to CrewAI. This is a bit of laborious type annotation, I would say, from the CrewAI. It would be great if they actually simplify that and probably add some other way to distinguish between different events. Yeah, this is pretty ugly, but I took pretty much this from an example and rewrite it in order to have this walk file that is going to be outputting a JSON line for each step of the agents. Yeah, pretty ugly, I would say, from CrewAI library. Probably they are going to essentially make it a bit better. Before starting the project, you need to have some tweets within the data and then tweets markdown. Here I have two of my pretty much latest tweets that I have currently, and this will be serving as an example of what and how you can essentially write the tweets. And another really important thing is to have this environment file, and here I've put it in an environment example file. Here you need to pass in your Grok API key and then OpenAI key if you want to use, for example, GPT-4o or Grok within the models. So I'm in the console within the TweetCrafter directory, and let me show you the contents of this file. So in order to run this project, again, I'm using Poetry. So I'm going to be using just run poetry or poetry run, and then I'm going to start the app.py, and in a bit you'll see that the crew is going to be running. And first we are having a look at the scraper. You can see that the crew is actually pretty fast. It is receiving the tweets that we've given it. It already wrote a tweet for us. It is saving the tweet. And this is essentially the result that we got from the project. It did 8 requests, and we actually have this output. We have the different versions of the tweet. So I'm back in the project, and after running the crew, you can see that we get this tweet.md file with the original tweet that was created by the writer, and then some of the versions that were created by the editor. And you can see that essentially the formatting is pretty much the same as the sample tweets, and it looks like the job was done pretty well. You can argue that probably a better model will focus a bit more on the technical details of this model, but again, for a first iteration this might be great. In my experience, of course, GPT-4o is much better at following commands, so you will probably get a lot better responses. And the next important part is the works directory. Here you can see the crew output. Let me take this out, and you can essentially see that, yeah, this is pretty sparse compared to what is going through the LLM. This is the complete output, which is again very sparse. You are essentially given some summary of what is happening. And if you look at the prompts, you see that we have a lot more information here, and we are going to be taking a look at this. So as a helper, I've created this notebook within the project, and it is within notebooks, explore walks. And here I'm going to essentially read all of the walks that were provided. I'm going to also import pandas, and we're going to have a look at what the prompts are, for example. And let's see what a prompt has. It has a timestamp, an event, and some text. Let's see what is the text of the first one. And here, this is much more telling compared to what we have before. So this is the event, LM start. And here you can see that the model is given a lot more information that we had before. This is essentially the complete prompt. You have this human, and this is essentially the role, the backstory, etc. with the goal. You can see right here. We have access to the tools, and this is the tool, essentially how it is presented to the LLM. Content, parameter, website, URL with a string, and then this is essentially the format that we are given. So this is essentially the React agent part of the CrewAI library. You have the tool, the action input, and then an observation. And here you can see that is essentially having a look at the URL that we're giving it. And if you look at this next step, the thought is to actually call the read website content tool with the website URL. And after that, you can see that the model is actually trying to scrape the data. You can see right here. Yeah, and you can essentially follow this process. Let's have a look at the final steps. So we are now at the senior tweet editor. You can see the custom tool that we have, save tweet, and essentially the same information. The observation is that this is going to be actually saving the tweet within this directory that is giving, or the path. And finally, this is the final tweets from the editor with the 3 different versions. So essentially everything is essentially put right here. And if you want to have a look at individual agents, you can see that they're doing pretty much 2 steps. From the scraper, we have the use of the tool read website content with the website URL, along with some walk information. Let's have a look at the researcher, for example. And here, the researcher is outputting essentially the summary or the research report based on the URL. And you can see that the summary contains new features of Phi3. Here you have some information along these lines. Yeah, it looks like this log is providing a lot of information about the different agents. Again, you can have a look at the writer. And you can see how the writer got to the original tweet. And essentially you can do the same for the editor. So this is a way to have a deeper dive in what agents are doing and what are the prompts that your models are having. This was pretty useful when I was essentially debugging this Crew and why some tools weren't able to be called correctly. For example, one mistake that I did was to not give a typing annotation on the save tweet, and I didn't have the string for the text. And essentially, Llama 3 was having a hard time to understand that this tool was actually needing a text parameter. So this is it for this video. We've seen how you can build an AI agents application that is writing and editing tweets based on provided URLs and some sample tweets for writing style. We've seen how you can wrap everything with a LangChain and the Grok API that is essentially using Llama 3. And we've seen how you can have a look at some of the walks that let us understand what is happening behind the scenes, because pretty much CrewAI is not that good with logging information. I'm not really sure if this is intentional or something that they need to work on. But yeah, you now have a way to have a look at the walks and the prompts that were given to the LLMs. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description. And I'm going to see you in the next one. Bye.